So we have 3 points given, point A, C, and B, which I plotted on Cartesian plane now. And the question asks us to find 3 options for the fourth point, so that A, B, C, and the fourth point D complete a parallelogram. And since we are in the vectors unit, we have to use what we know about vectors and what we know about vectors which are not position vectors. So I will look at the first option, is point D. The fourth point is going to be somewhere here. I will for now approximate it so that the shape looks like a parallelogram, and then I find its coordinates algebraically. So let's complete the parallelogram by connecting the points. And by adding the fourth point, this is how the parallelogram is going to look like. Let's say that this is point D. All right. So we can find the coordinates of point D from one of the vectors which D is part of. So let's look at the vector BD. For the vector BD, D is the head and B is the tail. I know the coordinates of B. The coordinates of B are 7 and -2, which is the tail coordinates. But I don't know the coordinates of the head. What else do I have here? I have another vector which is equivalent to vector BD, and that's vector AC. Why? For 2 reasons. First of all, because it's a parallelogram, so the opposite sides are equal, which means that those vectors have got same magnitude. Besides, opposite sides of the parallelogram are parallel, which means that those vectors are collinear. And collinear vectors with the same magnitude are considered to be equivalent vectors. So if I know the components of the vector CA, I can use them in order to find the coordinates of the point D. So let's start by finding the components of the vector CA. So since the vector CA is not a position vector, to find its components, we need to subtract the coordinates of the tail from the coordinates of the head. The coordinates of the tail are 2 and 8, and coordinates of the head are -1, 2. So by subtracting them, I get -3 and -6. So since the vector BD is equivalent to the vector CA, then BD vector has got exactly the same components. So BD equals -3, -6. On the other hand, if, let's say, the coordinates of point D are x and y, then I can say that the vector BD components can be written as x minus 7 and y minus -2. Why? Because Z is the head and B is the tail. Now I can use these two expressions and equate them in order to get unknown. So components -3 and -6 are equal to x minus 7, y minus -2. So now, by just equating the corresponding components, -3 is equal to x minus 7 and -6 is equal to y minus -2, I will be able to solve for the unknown variables. So x minus 7 equals -3, x equals 4, and y minus -2 equals -6, which means that y is -8. So the coordinates of this point, of the point D, are 4 and -8. So if you understand the concept, then in exactly the same manner, you can find the other two options for the fourth point.